Welcome to Two Projects. In this video, we are going to explain the project Development of an Interpretable Maritime Accident Prediction System using Machine Learning Techniques. Before diving into the execution, let me give you an overview of the project. So, maritime accidents like collisions, capsizing, fires, and explosions can cause immense harm to ships, cargo, the environment, and human lives. Predicting these accidents is very important for ensuring safety, economic stability, and environmental preservation. But traditional methods of predicting accidents rely on past data and expert judgment. So they have limitations such as not being able to analyze real time data and lacking interpretability. So, this project aims to create a user friendly system for predicting maritime accidents using advanced machine learning techniques like logistic regression, decision tree, random forest, ADA boost, voting classifier, and others. By analyzing data on factors like vessel name, the type of accident, weather conditions, and human factors, the system will provide insights into potential incidents. Through careful analysis and visualization of the data, unnecessary information will be removed to streamline the process. The data set will then be divided into sections for training and testing, and different machine learning models will be tested to see which performs best in terms of accuracy and speed. So, this is the workflow. Ultimately, stakeholders such as the maritime industry, regulators, and environmental agencies will benefit from actionable insights to improve safety, reduce losses, and protect the environment. And the overall objective of this project is to develop a reliable and interpretable maritime accident prediction system to enhance maritime safety and environmental sustainability. So, this is what happens in this project. Now we'll look at the software and hardware requirements to execute this project. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, back-end framework needed is Jupyter Notebook, database required is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we'll look at the algorithms built. So we have trained these machine learning algorithms in this project. We have compared these algorithms using different performance metrics like accuracy, precision, recall, and F1 score. And we have observed that logistic regression model has outperformed other machine learning models in all the performance metrics. So we have deployed logistic regression into the Flask framework. So we will be executing the project using Flask web application. Before execution, first we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. This is static folder which consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. So this .py file contains the information related to front-end logic. It includes code data in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is marine incident data, the required dataset. So this dataset comprises various data fields related to maritime accidents, including vessel name, accident type, human and organizational factors, ship type, weather conditions, and economic impacts. So this dataset facilitates the development of a predictive model to enhance maritime safety and mitigate environmental risks. So we will be using this dataset to train the machine learning models. So before training the machine learning models, we will perform pre-processing steps on this dataset like removing unwanted columns. So after removing unwanted columns, we have stored the pre-processed dataset in this file. So these are the leftover columns on which we'll be training the machine learning models. So the important columns are rain, air temperature, water temperature, persons on board, crew members, passengers, longitude and latitude of the accident area. And here the target column is the accident type, which contains three classes: 0, 1 and 2. 0 is for collisions, 1 is for other accidents, and 3 is for grounding. Sorry, 2 is for grounding. So these are the columns we have. So on this dataset, we'll be training the machine learning models. And this is model file which contains algorithm information. This file will be loaded into the project code during runtime to utilize the trained model. This is notebook Jupyter source file which contains a combination of code, graphs and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. This is test cases text document in which I have test cases which will be used during the execution. This is signup.db file. This file is the database file used to store user information. So it stores information like user signup details. This is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. This is the path. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command executes the Python script and performs a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the Flask framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. So paste it here and hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. And here we can see a login link, click on it. So here we have to give our credentials and click on the login link to sign in. And if we are new to the system, we have to register ourselves first. Click on the sign up link, fill in the details and click on register button to sign up. As I'm already a member, I'm clicking on the sign in link. I'm giving my credentials here and click on the login link. So we have logged in. It has redirected us to the predictions page. So now we have to fill in these parameters and click on the submit button to get the maritime accident prediction. So first we'll understand these parameters. The first one is rain. So it is the precipitation in the form of water droplets. Air temperature is the measure of the warmth or coldness of the air. Water temperature is the temperature of the water surface. Persons on board is the total number of individuals present on the vessel. Crew members is the number of individuals responsible for operating the vessel. Passengers is the number of individuals aboard who are not part of the crew. Longitude is the coordinate of the accident location, and latitude is also the coordinate of the accident location. Now we'll fill in these parameters. Rain would be 1, air temperature would be 285.92, water temperature would be 284.26, persons on board is 3000, 131. Crew members would be 961. Passengers would be 2160. Longitude would be 55.343 and latitude is minus 131.651. So after filling in the parameters, click on the submit button. So here we can see the prediction. A ship collision is possible. So according to the given set of parameters, the application has predicted ship collision may be possible. So ship collision is an incident where two or more vessels come into contact with each other. We'll try giving another set of parameters. Click on the home link. So this time rain would be 0, no rain. Air temperature would be 287.03. Water temperature is 285.93. Persons on board would be 3,362. Crew members would be 913. Passengers is 2,449. Longitude would be 39.265 and latitude is minus 76.598. Now click on submit button. So here we can see the prediction. Ship grounding is possible. So according to the given set of parameters, the application has predicted maritime accident as ship grounding. So ship grounding is an accident involving a vessel making contact with the seafloor or shore, resulting in it being stuck. We'll try giving another set of parameters. This time rain would be 0, no rain, air temperature is 289.55, water temperature would be 290.28, persons on board is 23, crew members would be 23, passengers count would be 0, longitude is 49.49 and latitude would be minus 124.68. Now click on the submit button. Here we can see the prediction. Ship grounding is possible again. So the application has predicted the maritime accident as ship grounding. So ship grounding would be possible according to the given set of parameters. Click on the home link. This time rain would be 0.352. Air temperature would be 275.37. Water temperature is 277.59. Persons on board would be 4. Crew members is 4. Passengers would be 0. Longitude would be 53.989 and latitude is minus 166.88. After filling the parameters, click on submit button. So here we can see the prediction as others. So here others is a catch-all category for accidents not specifically characterized as collisions or grounding, such as fires, explosions, or mechanical failures. We'll try giving another set of parameters. Click on the home link. This time rain would be 0.352. A temperature is 294.82. Water temperature would be 294.82. Persons on board is 8. Crew members would be 1. Passengers would be 7. Longitude is 47.61 and latitude would be minus 122.68. 93. Now click on the submit link. So here we can see the prediction of the maritime accident. So according to the given set of parameters, the application has predicted ship grounding is possible. Click on the home link. We'll try giving another set of parameters one last time. So this time rain would be 0. Air temperature is 289.82. Water temperature is 287.04. Persons on board would be 1824. Crew members would be 1003. Passengers count would be 2827. Longitude is 41.41 and latitude would be minus 70.925. Now click on the submit button. So here we can see the prediction as others. So the application has predicted others according to the given set of parameters. So others could involve fires, explosions, or other mechanical failures. Now click on the sign out link. So the project aimed to enhance maritime safety by developing an interpretable accident prediction system using machine learning. By analyzing comprehensive data on various factors, the system provided actionable insights to predict and prevent accidents, ultimately reducing economic losses and protecting lives and the environment.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.